something like this. So I'm going to try to share my screen again. Hopefully it's going to work this time. Okay, now I think it works, right? Yes,
Yeah.
I think it works. Okay, so I'm gonna write here some example of the last topic we did. I'm gonna let you a few minutes, everybody, to do that. So we say f of x right? G of x okay. Okay, so now I'm gonna do, for everybody, please try to find f minus g of -2, and then f plus g of x. All right, I'm gonna let you like about some good 5 minutes, everybody. Try to do these two. This is what we did last time before we, before the weekend. So now try to do this one before we go to the next topic, right? Go ahead, please.
For G, do we add the positive number first?
For G,
Yeah.
yeah, when you substitute x with -2, right?
Yeah.
You mean the first one, f minus g of -2?
So if we square the -2, it becomes a positive, and then the next number.
Yeah, it becomes a positive, yeah.
And then the next number is negative, so, but then the other number is -2, so do we add?
So now you have to dispense the PEMDAS. You have to do 7 times -2 first. You see, you have to 7 times -2.
That's what I did.
Yeah, exactly. All right.
But just not sure if I should add the 4 to the second number, or I should add.
Yeah, you should all of them. You should add the 4 with the second number you got, which is -14, and then the other one, -13. And then that's going to be your final answer for the G of -2.
I didn't realize it doesn't even matter.
It does. All of them, all the numbers you see there, they count. Yeah. All right. All right. I think it's been 5 minutes. So can somebody volunteer to give me the first steps? I mean, the steps of the first one, please.
And go.
Yeah, go ahead, please.
Substitute the -2 in the f of x formula.
Okay, so we see f of -2, which is how you get it? -7 times
-2.
plus what?
Oh, plus 11.
Yeah. And this gave you how much?
I accidentally put a -11 when I rewrote it. Let's
Okay.
see.
So
So
of-
-14 plus 11 is -3.
no, that's positive 14 because you have -7 times -2. That is positive 14.
Oh,
Plus 11 is 25.
I double messed up.
No, it's okay. And on the other hand, what you did, you already substituted. You also what?
-2 squared plus 7 times -2 minus 13.
Exactly, minus 13.
So for that, I got 4 minus 14 minus 13.
Yep.
And hopefully that was -23.
Yep, that is -23. So now, for your final answer, what is you going to do to both numbers you got here? You calculated. What you going to do with them for your final answer?
Subtract the f.
Exactly.
Well, subtract the g from the f.
Yes, you're going to 25 minus?
Minus 23.
Minus 23. Right? It's 25 minus -23, which end up to be 48, right?
Wait, where did the 25? Oh.
The 25 is the one we got with f of -2. Okay? Because this gives you, the formula says is f of -2 minus g of -2, right? F of -2 minus g of -2. So what we do here is actually we do two independent actions. Excuse me. So we do two independent actions. On one hand, we plug in -2 into the f, which that gives me f of -2, which is 25, right? On the other hand, we plug in -2 into the g. That gives me g of -2, which is -23. So now my final answer would be 25 minus -23, right? Which is 48. If instead of minus here, we had plus, we're gonna add them up. If instead of that, we had a multiplication, we're gonna multiply the two numbers. If instead of that, we have a division, we're gonna divide the two numbers, right? Everybody see that, what we did here? What we did here is separately, we calculated f of -2 and g of -2. That's it. That's the only math we did. F of -2 on one hand, g of -2 on the other hand, right? And these two actions are completely independent, okay? They are completely independent. So you plug in -2 into f, you get that number. You plug in -2 into g, you get another number. And whatever we ask you to do with them, you do that. If it is minus here, you're gonna minus the two numbers, right? If it is plus, you're gonna add them up. If it is a multiplication, you're gonna multiply them, etc., right? Now for the next one who gonna tell me what they did for the next one? Somebody else.
I can try, but I think I'm wrong.
Just try. Okay, let's us see. What did you do?
It's all I did was add them. I took -7x plus 11 plus x squared plus 7x minus 13.
So you think you're wrong because you must say, oh, this is too simple to be true, right?
Yes.
But this is true actually. It is what that is the answer.
Oh, okay.
Except now, if there is something to simplify, we go ahead and we simplify it.
So it would just be x squared minus 2.
X squared minus 2. Thank you very much. because the 7x's, they go, right?
Right.
The 7x's, they cancel out, and then we get x squared minus 2. So do not overthink something like that. They're just asking you to add the two functions.
Okay.
Yeah, somebody has a question? So we do not overthink this stuff right here. If it was a minus here, look, what would happen? If it was minus, we would do minus, right? If it was a multiplication, we would multiply them. If it was a division, we would divide them. That's it, right? Here, there is no other number to plug in. We don't have this one. This question is shorter than the other one, because in this one, you don't have to plug in nobody, right? You don't plug in no number. Okay. All right. So that was a quick review before we move on to the next one right here. And the next section is about exponential functions and equations. So we're going to see a new type of functions, right? That's 5.3. Exponential functions. And equations. Okay, so the exponential function is type of functions that are exponential. I mean, there we have exponents basically. So for that, we need what you call a base. That you're going to be, this number has to be positive and not equal to 1. Okay, that function right here, f of x, equal to b to the x power, b to the x power, right? That function right here, for any real number x, for any real number x, is called an exponential function base b. That is exponential function base b. That is exponential function base b, right? The b is a base. Now look now, the base cannot be negative, and the base cannot be different, cannot be 1, okay? The base cannot be negative, and the base cannot be 1. Now, why we don't allow the base to be negative? Why? For the simple reason, look at this. We allow the exponent to be any number, right? We allow the exponent to be any number. Now, if you look at the story of this exponents, let's go and look at the story of exponents right here, real quick. I know exactly what is, for instance, 2 cubed, right? I know that, right? Is what? Is 2 times 2 times 2, right? Okay. I know what is a negative exponent, 2 to negative 3. I know that is 1 over 2 cubed. I know the rational exponent, 2 to the 1/3. This is cube root, okay? Etc., etc. But if you allow the exponent to be any number, let's say, for instance, you take 2 to the pi power. You see that? That number is not a trivial number. When you raise 2 to the pi power, you see, everybody know pi? You see how pi is complicated? How we call numbers like pi? We call them, they are what? Numbers like pi, they are irrational numbers, right? They are called irrational. They are so complicated, you will never be able to write them as fractions, okay? Now, if you allow the exponent to be that complicated, right, you allow it. If your base is negative, then it's going to be a mess, okay? If your base is negative, it's going to be a mess, right? So that is why for the exponential function, we do a restriction on the base.
the number you are raising cannot be negative, because if that number is negative, you're going to be a mess, because you are allowing the exponent to be any number you want, right? If you allow the exponent to be any number you want, then you cannot raise the negative numbers. So let me see what my calculator says. Let me see what my calculator says if I allow this. Let me see. Okay, everybody see my calculator? You see my calculator, right? Let me raise -1. Okay, let me raise it to the pi power, and let me see what it's going to say. You see, it tells me 1. Okay, let me try -2. So I don't know why my calculator tells me that. This calculator, it does some restrictions, you know. But normally, the number. So this calculator, the only way it comes up with a number is they take pi as a whole number. You see, they take pi as approximation of pi. Okay, but normally in math, in the rigorous math, when you do -1 to the pi power, you cannot do that, because the answer must be 1 or -1. But since you are never able to write pi as a fraction, since you cannot write pi as a fraction, then that number would not exist. Now my calculator is doing some rounding, okay? My calculator is doing some rounding, so that is, you know, that is built into the calculator. They do some rounding, but if we take pi as a pi, then -1 raised to the pi power would have no sense. It would make no sense, because it should be either 1 or -1, but we don't know what it's going to be, because pi is itself very complicated. So that is exponential functions. So for instance, when you say f of x equal 2 to the x power, this is exponential base what? Base 2, right? If you say f of x is equal 5 to the x power, this is exponential base 5, okay? If you say f of x is equal to 1/3 to the x power, what is the base here? The base is 1/3, right? If you say f of x equal to 0.17 to the x power, this is base 0.17, etc., etc. These are the exponential functions. Now, how to evaluate exponential functions? Where you substitute, for instance, we have f of x equal exponential base 2 of x. If somebody asks me to write what is f of 1, where I plug in the 1, do I substitute, do I change the 2 or do I change the x? Tell me.
The x.
Yeah, X. But
X.
it's because it's just raising it to a power of 1, it remains as 2.
Exactly. We change the x. The base doesn't change. When you evaluate exponential functions, the base will never change, right? Everybody understand that? So it's going to be 2 to the 1 power, right? So I change the exponent, 2 to the 1 power, which is 2. Now, from the same thing, can you do f of 0, f of 2, f of -1, f of -2? Go ahead, everybody. Try to see, and if you have a calculator, your calculator can help you do that, okay? If you have a calculator, try to do that. Everybody. All right, so everybody, tell me, f of 0 is how much? You first write 2 to what power? 2 to the?
0.
0.
0 power, thank you. How much you got for that?
0.
You got 0? Okay, let's try with my calculator. 2 to the 0 power. 2 to the 0 power is 1, right? Any number to 0 power is 1, by the way. Any number to 0 power is always 1. Okay? So f of 2 is 2 to what power?
4.
2 to square, which is 4. Thank you. Okay, now comes f of negative 1. Is 2 to the negative 1 power, right? How much we get with that?
1/2.
You said you got 2?
No, I got 1. I got a fraction.
Yeah, a fraction, 1 over?
1/2.
1 over 2, thank you. You see, remember this fraction rule, this exponent rule, if you want to change an exponent from negative to positive and vice versa, you just flip the number. It's 1 over 2 to the 1 power. You flip the fraction, right?
Mhm.
That is 1/2, 0.5, right? F of negative 2 is what? 2 to the negative 2 power, right? Which 1 over 2 squared, which is 1 over 4, which is 0.25. So if I want to graph this function, exponential base 2 of x, I have 5 points. Let me see what are the 5 points I'm going to use, right? You see, I have this x here. I have this y here. I have f of 0 is 1. F of 1 is 2. F of 2 is 4, right? F of negative 1 is 1/2. F of negative 2 is 1 over 4. So I'm going to use these 5 points to graph exponential base 2 of x. Okay? So now let me do my thingy right here. Right, and then I have this right here. Okay, so right here I have, let me put my units. I have 1, 2, 3, 4, etc. -1, -2, -3, -4, 1, 2, 3, 4, etc. Right? Okay, I have 0, 1. 0, 1 is here. I have 1, 2. 1, 2 is here. I have 2, 4. 2, 4 is here. 2, 3, 4. 2, 3, 4 is here, right? I have -1, 1/2. 1/2 is here, so -1/2 is around about this. I have -2, 1/4 is it's closer to the axis. So what I got at the end? I got my graph looks like this. That is exponential base 2 of x, right? You guys see that? Now, from what we learned before, from this, what is the domain of this graph right here? Before you answer, you have to keep in mind you have arrows all over, right? At the end of the graph, you have arrows. So what is the domain? From what x to what x? What do you think?
Negative to positive infinity.
Exactly. Thank you very much. Because of the arrows. Because of the arrows, my graph starts from negative infinity and go all the way to positive infinity. All right, everybody? So the domain for exponential functions is always negative infinity to positive infinity. How about the range? What is my lowest y value? What is my highest y value? What would be my lowest y value? Because look at the direction, look at the trajectory of the left side. It looks like this left side will never cross the x-axis, right? We'll get close to it, but we'll never cross it, which means my graph will never go over the negative y's, right? So my lowest y value will be 0. And because of this arrow here, it's going to be all the way to infinity. That's going to be the range. So the range will be from 0 to infinity. This is just a side comment, okay? That is, if I want to graph exponential base 2 of x. But very importantly, do everybody see how we plug in the numbers here? All right. So now if I give you another exponential function, I ask you to plug in the numbers. I have g of x or f of x equal 1/2 to the x power. Find f of 0 equal f of 1 equals f of 2 equals f of -1 and f of -2. Go ahead, please, everybody. You see, if you don't like 1/2, you can replace 1/2 by what number? If you don't like the fraction 1/2, you can replace it by what number? Can somebody tell me? Let's say I don't like 1/2. You can replace it with 0.5. Thank you. If you don't like 1/2, you can replace it with 0.5, and then you're gonna go ahead and use your calculator to help you out. Remember, you are allowed to use a calculator, right? So I don't take no chance. If I'm allowed to use a calculator, I use a calculator. Okay. All right, go ahead, please, everybody. And then how to graph it? Then you do your point here. Exactly what you did before. X here, Y here. 0, 1, 2, -1, -2, and then you graph the points. Go ahead, please. I let you have some good 5 minutes for everybody to figure it out. All right. Okay. F of 0. You see 1/2 to the 0 power. How much is that? Again, you can use your calculator again, right?
1.
It is 1, right? That is 1. F of 1. You see, if you leave 1/2 as a fraction and you want to use a calculator, you have to put the parentheses. Okay? You see, 1/2, if you don't put the parentheses, then if you put an exponent, your calculator will give you something wrong. Okay? So 1/2 to the 1 power, how much is that?
Wait, I'm sorry. Why is
Yes.
that 1?
Yeah, any number raised to 0 power is 1. Now look, look what I was saying. Everybody sees my calculator?
Yes.
Okay, if you do 1/2 to the 0 power, look, if I dismiss, if I put a parentheses around 1/2, 1, you see I put 1/2. I put parentheses right here, and then I raise it to the 0 power. I say raise to the 0 power. You see, it's give me 1, right? Now let's do it without parentheses. Let's do 1/2, and then I raise it to the 0 power. You see here, the parentheses are, I mean, so here it's gonna, again, you see, this calculator is like some type of smart calculator. So it's gonna do the right way, because it's gonna auto correct that. But let me show you. If you don't put parentheses right here, if you do 1/2 to the 0 power, who is raised to the 0 power? Who is raised to the 0 power?
The half?
Is it? This way right here, if I write it this way, are those, is the whole fraction raised to 0 power, or is it only the numerator that is raised to the 0 power?
I mean, I don't know. I thought it was the whole thing. So it's just
No, the whole
numerator?
thing is when you do this. That is the whole thing, right? If you don't do the whole, if you don't do this, if you just do this here, only the 1 is raised to the 0 power, right? That is very important. If you do that in a calculator, this calculator, they autocorrect. They do it, you know, it's kind of auto correction. But here, when you do this way, we see clearly only the 1 is raised to the 0 power, right? That will give me 1/2. You see, that is why parentheses are not optional in math. They are not an option. They are obligatory. Okay, when you write things, you see, if I don't put around here parentheses, if I just do this right here, you know, that is different from this. Okay, so it's very different. All right. So what is f of 2? Is 1/2 the second power. How much is that? 1/4 what? 1/4?
4.
4. 0.25, right? This is 0.5. And this is 0.25, 1/4. Now, okay, now comes this one. What is 1/2 raised to the -1 power? Again, you can use a calculator. You don't have to struggle with that. If you have a calculator, 1/2 is 0.5, right? 0.5 raised to -1 power. I'm sorry, so let me, 0.5 raised to -1 power. That is 2. Okay, you don't have to, if you are allowed to use a calculator, please use it, okay? What is f of -2? Is going to be 1/2 raised to the -2 power. Again, use a calculator again. 1/2 is 0.5, right? 0.5 raised to -2, which is 4, right? Okay, so now what are my 5 points? I have 0, 1. I have 1, 1/2, 0.5. I have 2, 1/4, 0.25. I have -1, 2. I have -2, 4. So my 5 points, let me put them here in red. I have 0, 1, -1, 2, -2, 4, 1, 1/2, and this. So this is the graph of exponential base 1/2. Same domain, same range, 2 opposite behaviors, right? One of them is increasing, going up. The other one is going down from left to right, okay? One of them is going up from left to right. The other one is going down from left to right. When you graph an exponential function, your graph will always be like either like the blue one or either like the red one, always. According to what? According when the base here, the base is bigger than 1, right? And here the base here is less than 1. When the base is bigger than 1, your graph will go up from left to right. When the base is less than 1, your graph will go down from left to right, okay? Again, so this is Math 103. It's just like it's an introduction. It's just an introduction to the. It's just an introduction to the exponential functions. If you go to the next class, you're going to see more. If you go to the next class, you're going to see more, etc., etc. But here we just introduce things, exponential functions, and we give you an idea how the graph will look like. If you graph exponential functions, whatever they are, if you graph them, your graph will be either like the blue one, if the base is bigger than 1, like exponential base 5, exponential base 6, exponential base 7, whatever. If the base is bigger than 1, your graph will go up from left to right. Or if your base is a fraction, like 0.5 or 0.3 or 0.4 or 0.7, your graph will go down from left to right, okay? But in any case, in all cases, the domain is -∞, infinity, and the range is 0, infinity. Okay, that is the introduction to exponential functions.
Is this type of math and statistics?
Yeah, statistics will probably use the basic statistics. Will not use this stuff a lot. The basic statistics. Now, when you go to the what I mean, the basic statistic is like the introduction to statistics, which is like math 153.
Okay.
If they use exponential functions, it won't be a lot. Calculus uses a lot of exponential functions. Calculus does. Okay. Basic statistics, maybe not. Advanced statistics, like, you know, some advanced statistic, which is definitely more math in it, more like more calculus stuff, then you're gonna encounter all type of math, right? But 153, I don't think you're gonna encounter a lot of stuff of, you know, for a lot of functions, stuff like that. The distribution, what you call the distribution, you have some functions that are like shaped like a bell, you know, some functions that are shaped like a bell, like this. You see, the graph, this type of graph are not the graph of exponential functions. Okay. Okay, so after that, after we have a glimpse of what is an exponential function, now we're going to focus on how to solve exponential equations. How to solve exponential equations. Exponential equation. Again, this right here is the basic type of equations. Not all of them, the basic type of equation. Now let me tell me, if I have b to the x power is equal to b to the y power, right? If this. Okay, what we obligatory should have for this stuff to be true, obligatory we should have what? Common sense. Obligatory what? Isn't it the same b? It's the same base, right? If you raise the same number to two different exponents, right? Can you have the same outcome? Is it possible to have the same outcome?
Yes.
If I raise, I mean, let me give you an example like that. Let's look right here. If I say, is it possible to have 5 cubed is equal to 5 squared? Is that possible?
No.
No.
It's not possible, right? If I see that, if I say 5 cubed is equal to 5 to the x, right? What is the only value x could be?
3 or cubed.
The only value x could be is 3, right? Everybody agree with that? So, which is here, that is my point. If you raise the same base to exponents, it means these exponents must be equal. Then x must be equal to y, right? Is it logical? If the two exponents are different, there is no way you can have the same number. There is no way, because it's the same base again. If they are different bases, yes, but it is the same base. This is base b here, and this is base b, right? So x has to be equal to y, right? So we're gonna actually work on that situation, basically. That is like the easiest setups. So if we say solve this, we say solve 3 to the 2x plus 1 equal to 3 to the, I'm sorry, 3 to the 5, right? We see the same base, right? Okay.
Right.
Base 3. What this means for the exponents? They must be equal, right? We agree on that. Because we have the same base, the two exponents must be exactly equal, right? Okay, which means this exponent must be equal to this exponent, right? Because we have the same base. right? Which means 2x plus 1 must be equal to 5, and then we solve for x. You see that, everybody? These are the type of equation we're going to solve in OED 3. Okay, if you go to another level, you'll see some other equation, but basically all the equations we're going to solve, they will come down to this. Okay, something like that. Now, how you solve for x now? What you do first? Subtract.
Subtract the 1.
Subtract 1. We get 2x equal to what?
4.
4. And then we divide by
2.
So we get x equal to. That is my solution. All right. And when you check it out, when you put x equal to 2 times 2 is 4, 4 plus 1 is 5. So we get 3 to the 5th power equal 3 to the 5th power, right? So that is the first type of equation. This is the easy one. That is the easy one right here. What is the second type of equation? It's like this. The second type of equation is we say solve 2 to the 7x minus 13 is equal to 16. You see? At first here, the other number is not even written in exponential form, right? At first. But here, the question is, can we write 6 as some power of 2, 16? Is 16 some power of 2?
Yes. It's
Everybody is thinking about that. 16 is 2 to what power?
4.
Everybody agree with that? You see here, in O83, we don't put any number on the other side. We don't put any number. If you put any number, then we would not know how to solve it. But here, 16 happens to be what? 16 happens to be 2 to the 4th power, right? Okay. So in O83 right now, as of right now, we don't need, for instance, we don't know how to solve if this was, for instance, another number like 15. Because for the simple reason, we cannot write 15 as a power of 2, right? For now, in O83, we don't know how to do this in O83. We don't know how to do this for now, okay? But 16 happens to be exactly some power of 2, right? 2 to the 4th power. Now, what is my subsequent, what is my equation then I get from this? Since I have this equal to 2 to the 4th power, what I'm going to equate? What is my next step now?
7x minus 13 equals 4.
Exactly. Now I say 7x minus 13 equal to 4. Now I say this exponent must be equal to this exponent. All right? And now I solve it. What I do, I add 13, I get 7x is equal to 17. I divide by 7, I divide by 7. I guess x equals 17 over 7, right? Everybody sees the second case. The second case is, on the other side, you have a number, but luckily, very luckily, that number happens to be an exponent, an exact exponent of an exact power of the base, okay? That is the second type of equation you will see in the next assignments. What is the third type of equation? That is the more complicated in our category. For instance, solve 5 raised to the 9x minus, let's say 4 equal to 25 raised to the 3x. Okay. All right, you see here, on the left side, I see base 5. On the right side, I see base 25, right? But 25 happens to be what? 25 happens to be 5?
Squared.
5 squared. You see, that is not a chance. If you don't put 25, if you put another number, randomly, if you put 30, this stuff becomes very hard to solve for our OAD3, right? The fact we put 25, or we put another number that is an exact power of 5 is intended, right? If you don't do that, it becomes hard. Okay, so this is 25 happens to be 5 squared, and then I don't forget it is raised to what power? 3x. Now go back to the exponents rule, everybody. When you have 5 squared all raised to the 3x power, what you do to the two exponents? What you do to them? You add them up, you multiply them, you subtract them. What you do?
Add.
You add? Are we sure?
Multiply.
Okay, so let's pick an example right here. 2 cubed, and then we put 4 here. It's going to be 2 to what power?
Is it 12?
You multiply them. Okay, everybody? You multiply the two exponents. If they are compounded, you multiply them. Okay? Everybody see that? So this becomes 5 to what power? 2 times
6.
2 times 3x, which is 6x, right?
Why isn't the square the same level as a 3x? Like, why wouldn't it be 3x plus 2?
No, it would be 3x plus 2 if it was 5 squared on one hand times 5 to the 3x. That is very different, right? Then you would add them right here. If you have two separate bases, same base, you multiply them, then you would do 5 to 2 plus 3x, okay? But if it is compounded, if it is 5 squared and then 3x, you have to multiply them, right?
Okay.
Right. So that is a good question because it allows us like to lay down the two cases, okay? In this case, the two exponents are compounded, okay? When they are compounded, we always multiply them. So now what is the subsequent equation now what we have? What is the equation we will get? Now that we have the same base, we will write what? What is the next step?
9x minus 4
Is equal to what?
to the 6 power 6x power.
No, exactly.
The 5.
9x minus 4 must be equal to the 6x. That's going to be my, and then I solve for this. I add 4, I subtract 6x, subtract 6x. We add 4, we add 4. So we get 3x is equal to 4. So we get x equal to 4 over 3, right? These three equations in OAD3 are the ones we're going to do in this class. You will not see another one which is different, right? So I'm going to give you, in each category, I'm going to give you one of them, and then you try to do that, please. The first one is the easy one, right? I mean, I say easy because there is nothing else to do. It's time. The second one is 81, right? And the third one all right, everybody, please go ahead and solve these three. Each category here is represented, right? Each category is represented. Try to solve these three right here. All right, so you can go ahead, and it's almost time. So somebody, the first one right here, the first one that if you see something like that, please don't overdo it, right? So what is the equation you're gonna set up? Somebody tells me what equation you set up for the first one.
Isn't it just 5x minus 17 equals 2x plus 1?
Exactly. You see, because we have the same base, because you have base 9 is 5x
Girl,
minus
hold on.
17.
I need you to be quiet.
Yeah, and then we're gonna solve it, right? Okay, tell me, what are the steps you took to solve this? What you did first?
Okay, I'm gonna bring 2x over the 5x, so minus 2x both sides.
Uh-huh.
And then I'm also gonna bring over the 17 to the other side, so plus 17 plus 17.
Yep. Mm-hmm. So we get
So
what?
3x equals 18.
Uh-huh.
Divide 3 both sides to get the x by itself.
X equals 6. Thank you. That's it.
Okay.
Okay, the second one. 81 happens to be what? 81 happens to be, somebody tell me, 3 to what power?
The fourth power.
3 to the 4th power. Thank you very much. Again, the fact you have 81 on the other side is no chance, right? It's not a random number. I've put 81 because if it is not 81, it's going to be more, it's going to be harder. If it was 80, it's going to be harder. If it was 83, it's going to be harder, right? Okay. So 3 to the 4th power. Now, what's the equation we're going to set up now?
7 minus 4x.
Equal to 4.
Equals 4. Mm-hmm.
Yep. Now tell me what steps you did to solve this.
I've subtracted 7 on both sides.
Uh-huh.
So I have negative 4x equals negative 3.
And then
divide negative 4 on both sides.
Uh-huh.
Which makes x equals 3 over 4.
Yep. Thank you. Okay, now the last one, okay, the 8 happens to be 2 to what power? 8 happens to be 2 to the somebody tells me 2 to the
third. 3.
To the third, right? And then we have 4x was there in the first place. So remember, we said in this case, we have to multiply the exponents, right? It's going to give you 2 to what power? If we multiply the 2 exponents, you get 2 to what power? 12x. Okay. So now you can go ahead and set up the equation. 11x plus 3 is equal to 12x. You subtract 11x, so you get 3 equal to x, right? So these are in O83, these are the 3 types of equations you're going to see in the exams in O83. If you go to the next math class, like 163, you're going to see some of the type of equations, okay? But in O83, we just limit ourselves to these 3 types, all right? So, all right, everybody. I wish everybody a good holiday break. So please, you know, you have like a week of break. You have to manage somehow to do some math, right? Before you forget everything, you know. And the turkey will not help, right? Turkey doesn't help. I wish everybody good holiday and see you next week.
Thank you. Same to you.
Thank you.
Good Thanksgiving. Thank you. Bye, everybody.
Bye-bye.
Bye.
Thank you.